Have you ever wondered how it all began? Humankind has been pondering that question since the moment we first gazed up at the stars. Now, a million or so years later, a team of scientists in Europe is on the verge of unlocking the secret of the Big Bang, that explosive split second when our universe was created. The scale of this experiment in a bunker deep beneath the Swiss Alps is, frankly, mind-blowing. It's the largest engineering project since man went to the moon. And if it works, we may finally get an answer to the most baffling mystery of all. It's fitting that mankind's greatest quest to solve the mysteries of creation is going on alongside a stunning example of nature's work, the Swiss Alps. My guide on this journey of discovery is Australia's leading astronomer, Professor Fred Watson.
This base here has been gouged out by a glacier over the last 100 million years or so. Makes you feel a bit small.
Very. But science class was never like this. The highest rail line in Europe climbs the northern face of the Eiger and delivers us to an astonishing scientific outpost, far above the clouds and the lesser concerns of life.
I have spent so many years working in telescope domes like this that I've started to look like one.
At the high-altitude research station of Jungfraujoch and Gornergrat, you just can't help wondering about our place in the cosmos.
And telescope domes like this are what really set us actually on the trail of finding out the origin of the universe.
The Big Bang.
The Big Bang, right back to the beginning.
The beginning has always been the biggest question of all. How did we get here? Where did the universe come from? And back in the 1920s, science gave us an answer. It all started with the Big Bang. What is the Big Bang?
The Big Bang is an event that took place about 13.5 billion years ago. It's the event that we believe gave rise to the universe that we see today, and everything in it, of course.
And now, in the most ambitious science experiment in history, a giant contraption built deep underground is recreating the moment of the Big Bang. When a single original atom expanded into billions of flying particles that came together to form life, the universe, and, well, everything.
From the Earth to the Sun to the other planets and the stars and galaxies, all those things were formed from the Big Bang and are essentially in the Big Bang. But it's the creation of space and time and matter that are the really interesting things. And of course that all happened in the first gazillionth of a second. And that's where this machine comes in.
To recreate the Big Bang requires a Big Bang machine. That's the nickname they've given to the monster that they've built right here in Geneva. So big, it straddles the Switzerland-French border. Let me show you. It starts just over here, around about where that brown dome is. Now, if you follow it around all the way underground, right out to the horizon, as far as the eye can see, and then along into the foothills of those mountains. It swings back around in an elliptical shape and back to the brown dome. 27 kilometres long, a kind of scientific racetrack. The $8 billion Large Hadron Collider is designed to replicate the exact conditions of creation on a smaller scale. It's all about protons.
The proton is a subatomic particle that is common throughout all of nature. So it's one of the fundamental building blocks of matter.
The protons are sent whizzing around the Hadron Collider circuit in opposite directions, calculated to meet head-on in billions of explosive collisions. All monitored by a control room full of excited physicists.
Each of these little collisions that we're making, the energy is going to be the same as a millionth of a second after the start of the Big Bang. That's the conditions we're replicating inside the machine every 400 billion times a second or something like that.
The figures and formulas might be mind-boggling to you and me, but Australian scientist Dr. Anna Phan, a physics graduate from Melbourne University, says there's nothing complicated about what they're seeking here.
Some deeper understanding of where we come from, where the universe comes from, and how we see it, and our place within it, because we tend to be a bit self-absorbed at times and worry about our own little lives and what are we going to eat next and what are we going to watch next. But here we're always asking the big questions.
The mechanics of the machine, the wonderful technology that's there is really just a vehicle to get us to the answers.
The one answer that's eluded even our greatest scientific minds is how the Big Bang's particles managed to form together into solid mass, and even more astonishing, create an environment on Earth that led to human existence. That's where God comes in, or at least the God particle. The theory put forward by Scottish physicist Peter Higgs is that one special particle dictated the formation of mass, and so is responsible for creation itself.
So the idea of the God particle, the Higgs boson, is that there is something that we can pin down as being a particle that gives everything else this property of mass. In other words, a single particle that would make things seem heavy or light depending on how it was arranged.
The greatest aim of this entire experiment is to find the God particle amid the billions of colliding protons using this giant detector.
And that's what they're looking for, first up.
That is one of the critical things that the Large Hadron Collider has been built for.
Australia is one of 80 countries contributing to the project, with $2.5 million and some of our most brilliant young physicists hoping to find the elusive particle that started it all.
Well, that would be huge, just unbelievable. For me, I mean, personally, I would like to see that within my lifetime. I really would.
Is it all it's cracked up to be? This machine? I mean, is it going to deliver something spectacular?
Yeah.
Yeah. Can I have a show of hands? Who thinks this machine will definitely find the God particle, the Higgs boson?
Oh, really?
2. $8 billion, I can't even get a majority. What? Building this amazing machine is itself a stunning scientific achievement. So while this might look like a giant water pipe, an old-fashioned water pipe, you're telling me it's really a magnet?
This is a very large magnet. It's used to bend the particles around in a ring over a 27-kilometre circumference, and it has 2 beam pipes. So there's one beam of particles going this way and one coming this way. Okay?
The engineer, making sure all those speeding particles collide where they're supposed to, is a very clever New Zealander, Dr. Alec McPherson.
The particles, when we've accelerated them, go to 99.9999998% of the speed of light.
You sure about that?
The last digit is dodgy.
E equals mc squared. What a ride.
If you're having trouble getting your head around that kind of velocity, here's another way to look at it.
This luge seems pretty quick to me, but if I was one of those tiny particles, at this rate it would take me 40 minutes to do a complete circuit of the Hadron Collider. In a Formula One car, I could do it in 5 minutes. But in reality, they're being shot around at rates even faster than that, at speeds that are almost impossible to comprehend.
If you were just watching the protons, they'd be going around 11,285 times a second.
11,000 times in a 27-kilometre circle, a second.
The speed of light is very fast.
If it's starting to sound like science fiction, prepare for warp speed. The Hadron Collider is boldly going where no physicist has gone before.
There might be more dimensions than what we can see, but which are hidden from us on the normal, everyday scale.
Another dimension.
Not just one, probably more like another 6.
Well, you're almost talking about time travel.
Yeah, and that's right. Subatomic particles take on all kinds of different characteristics. They can, for example, be in 2 places at the same time, and that is truly weird.
If a particle can transfer from one dimension to another, perhaps Captain Kirk and his crew were onto something.
Are you talking about things like a Star Trek application, beam me up, beam me down?
Well, who knows whether we will ever be able to beam human beings, as in Beam Me Up, Scotty, is a very interesting question, but it's not one that you should rule out. The only thing I would say about that is that I would not like to volunteer to be the first person to be tested on this idea.
Results in this grand experiment won't come overnight. It will take years to process the data that's being gathered. But one thing is certain. What's happening here, under the Swiss Alps, in one way or another, will change the world as we know it.
It has the potential to uncover new rules which may take us forward in a quite different direction in physics from the way physics has been going so far, which is exactly what happened when Einstein came along.
It's phenomenal thinking, isn't it?
It's far out, yeah. Science is often in a kind of symbiotic relationship with science fiction, because what is one day's science fiction is often tomorrow's science.
Coming up.
Mother's Day